Imagine Earth halting its spin for just 1 second, a blink of an eye, but the consequences of that pause, catastrophic. And thanks to recent scientific breakthroughs, we can now explore how our planet's rotation subtly shifts every day and why that matters more than you might think. This past summer, our planet's day actually shortened by up to 1.5 milliseconds, a tiny change, but one that's measurable and significant for high-precision systems like GPS. These fluctuations aren't just academic curiosities. They have real-world implications that touch everything from our daily lives to the future of our planet. Since the turn of the millennium, melting ice sheets have been slowly but surely affecting Earth's spin. This has added approximately 1.3 milliseconds to our day length per century. If greenhouse gas emissions remain high, that figure could potentially double to 2.6 milliseconds by the year 2100. It's a stark reminder of how human activity is literally changing the way our world turns. But the effects don't stop there. Scientists have discovered that by the end of this century, the North Pole could shift by up to 27 meters. This drift is caused by the redistribution of mass as polar ice melts, and it has profound implications for navigation and our understanding of Earth's geography. Imagine the challenge of updating every map and GPS system to account for a wandering pole. These subtle changes pale in comparison to what would happen if Earth's rotation actually paused, even for just a second. At the equator, our planet moves at a staggering speed of about 1,600 kilometers per hour. If that motion suddenly froze, everything not firmly anchored to the ground would be flung eastward at that incredible velocity. The devastation would be unimaginable. The atmosphere, still spinning while the solid Earth below it stopped, would unleash winds far stronger than any hurricane we've ever experienced. These superwinds would flatten buildings, uproot entire forests, and reshape the surface of our planet in a matter of minutes. The sudden transfer of momentum would likely crack Earth's crust, triggering earthquakes and volcanic eruptions on a scale we've never seen before. But the chaos wouldn't end there. As Neil deGrasse Tyson once said, not only would you be launched into space at over 1,000 miles per hour, but all the air and water would rush to where you were just standing. The redistribution of Earth's oceans would cause tsunamis of unprecedented size, drowning coastal areas and reshaping continents, which is generated by the motion of molten iron in the planet's core. This geodynamo is crucial for protecting us from harmful solar radiation. A disruption to this system could leave Earth vulnerable to space weather, with potentially dire consequences for all life on the surface. The planet's shape, which bulges at the equator due to centrifugal force, would begin to change. This would cause further geological instability, potentially triggering more earthquakes and volcanic activity for years to come. The temperature extremes on Earth would become even more pronounced. Without rotation, the side facing the sun would experience constant scorching daylight, while the dark side would plunge into a deep freeze. This temperature imbalance would create massive storm systems as the atmosphere tried to equalize the heat distribution. This would mean one side of the planet would always face the sun, creating a permanent day side and night side. Life as we know it would be impossible in most areas, with only a narrow habitable zone along the terminator of the line between day and night. The real changes we're observing in our planet's spin have significant implications. The shortening of days, the drift of the poles, and the influence of climate change on these processes all point to a dynamic Earth that is constantly changing beneath our feet. These discoveries underscore the importance of continued research into Earth's rotational dynamics. As we face the challenges of climate change and its myriad effects on our planet, understanding these subtle shifts becomes increasingly crucial. They affect everything from the accuracy of our GPS systems to long-term climate patterns and the distribution of water across the globe. Moreover, these findings highlight the interconnectedness of Earth's systems. A change in ice mass at the poles doesn't just affect local ecosystems. This holistic view of Earth as a complex, integrated system is essential for addressing the environmental challenges we face. As we look to the future, the study of Earth's rotation offers both warnings and opportunities. It warns us of the far-reaching consequences of climate change, but it also presents opportunities for innovation in fields like timekeeping, navigation, and climate modeling. In conclusion, while we don't have to worry about Earth suddenly stopping its spin, the real changes occurring in our planet's rotation are a powerful reminder of the dynamic nature of the world we inhabit. They underscore the need for continued scientific research and global cooperation in understanding and protecting our planet as we face the challenges of the 21st century. This knowledge will be crucial in navigating the complex interplay between human activity and the natural systems that sustain us all. The next time you watch a sunset or feel the turning of the seasons, remember that you re-experiencing the effects of a planetary dance that has been ongoing for billions of years, a dance that is subtly changing even as we speak. It's a humbling thought, and one that should inspire us all to take a closer look at the incredible world beneath our feet.